So you want to learn how to burn things inside of Blender? Well, for that you're gonna need to learn one of the most amazing effects you can do with geometry nodes and the simulation zone. An effect that can allow you to create not only burning things, but peeling a surface, infect a mesh, transition between materials organically, or even spawn particles. I'm talking about the spread solver. I will teach you how to build the basic setup, and I will also take you through the creation of an advanced node group that you will be able to reuse on your future projects. Then we will apply this on both a cloth simulation and a smoke simulation, and finally we will do a bit of shading to bring the effect to life. So if you're ready, let's get started. Okay, so when you open up the file, you will find a plane which has the dimensions of an A4 sheet of paper and also a bit of geometry. We can start by opening up a geometry node window and ask ourselves, what is a spread solver? It's a way of simulating the spreading of an attribute across the geometry of an object by blurring it. So let's start by calling a store-named attribute node. The attribute will be a float that we will call mask. Now we need to assign value to this attribute. A very basic and effective way to do so is by creating a vertex group. So jump in edit mode, select a vertex and assign it to a vertex group that we will call start in this example. Now, if you call your vertex group inside GeoNodes using a named attribute node, you can preview it with Ctrl, Shift and left click on the attribute and the geometry stream. As you see, we have a black and white value. After that, we can use a blur attribute node and start to understand that if we blur this value each frame, eventually we will get across the geometry. So let's call a simulation zone and plug your store-named attribute setup inside this zone. Make sure you're previewing the mask output, press play and see what happens. Nothing. This is because we are saying to Blender that the mask attribute is just equal to the blurred vertex group. We need to update it each frame for it to work. So use another named attribute node and use the mask attribute as the input. Add the vertex group on that attribute and blur the result. Now press play, and there it is! You can see we are getting somewhere. Now we need to bring it to the next level. As of right now, the effect is first a bit slow and second very linear. So an easy way to influence the speed of the effect is to use a color ramp, plug it at the end of the operation and drag the white stop closer to the black stop. Watch out, don't overdo it, okay? The second speed control we can have is some subdivision parameter. So in this case, I'm going to use a subdivide mesh node and plug it right before the simulation zone. If I increase the subdivision count, this will slow down the effect and also allow us to add more details to the simulation. For that, we are going to use a noise texture alongside a trusty old map range node, in order to play with the contrast of the texture. Set the noise scale to 8, for example, and adjust the contrast of your texture. If we plug the map range into the weight socket of the blur attribute, we will have different parts of the mesh blurred by a varying amount. Yeah, super pronunciation there. As you can see now, we broke the linear aspect of the spread. One problem though is that we have some parts of the noise texture that are equal to 0. So effectively, we are not blurring by any amount on those parts. So to fix that, we can just increase the two-min value of the map range to a small value like 0.005. And we fixed this little issue. And that's it guys, you effectively built one of the coolest effects you can do with just a few nodes. But that's not all. Now I'm going to show you how you can spice it up so you can have multiple ways of creating your starting value. Let's say you don't want to manually select your vertex, but rather select a bunch of them randomly. You can do so by using a random value node set to Boolean and lower the probability. So now, with the seed socket, you have a way to iterate faster. Use a switch set to float in order to be able to juggle between your vertex group and your random selection. Okay, that's cool. But what if you rather want to have an object initiate the starting value? Say no more, dude. In this case, I'm gonna use an empty. Use an object info node and make sure you pin your GeoNode window so when you click out of it, it won't disappear. Select your empty and call a position node. We want to subtract the location of the empty from the position of our point and find the length of that vector. Alternatively, you can just use a vector mass set to distance. Finally, use a map range. Flip the toMin and toMax and reduce the from min value to 0.01. Let's use another switch to change between our vertex selection method and our object selection method. I'm gonna drag my empty outside the plane area, press play, and as the timeline goes by, I'm dragging the empty on different parts of the plane. And as you can see, the effect is working quite nicely, right? The final way I'm gonna show you is to use a curve. It's a bit more stylish, but definitely has its use cases. I'm gonna use a Bezier curve, delete everything inside edit mode, and then draw a squiggle using the draw curve function. Back in the GeoNodes window, I'm gonna use a resample curve, a curve to mesh, a geometry proximity set to edges, and oh yeah, don't forget the trim curve node. Let's duplicate yet another switch to switch between the object method and the curve method. If I lower the trim end value, you can see the curve will reveal itself if we animate it. Be careful, don't trim the curve to 0 or you will get this all white value. So just use a very low value like 0.001. Set your keyframes, play the effect, and boom, you got a nice wake going through your mesh. Amazing, isn't it? Finally, because to me it's more convenient to set it this way, I'm gonna plug the color output of the color ramp in an empty socket of the simulation zone. I will set this socket to a float inside the end panel, and if you scroll left of the node tree, you will see that a socket appeared. Click and drag it onto the value socket of the store named attribute. Alright, we can now build the node group that you will be able to mark as an asset and reuse anytime you want. First, let's frame all the nodes to have a cleaner node tree, select them and press Ctrl G to create the node group. I start to create input to reference the names of the mask attribute and start vertex group. Then I add all the parameters I need to control the vertex selection. I will add a new panel using the plus button and I'll drag and drop each parameters inside of it, making sure I have the insert into panel and insert after socket info bubbles showing to not make any mistake. After that, it's all a matter of creating the inputs that are the most important to you. Here you can see I'm adding the noise parameter panel. I start by creating another switch node and plug the result of the noise in the true socket. Just don't be like me and forget to input 1 in the false socket, otherwise it means the weight property of the blur attribute will be equal to 0, making it useless. I will speed up this part because it's quite repetitive and boring, plus you can figure it out rather easily on your own. At the end, select all your group input nodes and press Ctrl H to hide all their unused sockets. You can finish it off by plugging the float output of the simulation zone inside the group output and call it mask output. That way, you will be able to preview the mask outside the node group. Once you're finished, you can import this node, append it, or better, create a blend file and mark it as an asset, and you'll have it at the start of every of your projects. Nice, we are almost to the simulation part. I hope you're hanging tight. We need to create patches of paper. For that, we will split the edges of the mesh using a setup I've shown you in a previous tutorial. So get yourself a noise texture node, a position node, a Voronoi texture, and finally a mix color node. Distort the Voronoi texture like you will distort any texture in the shading tab. Use the linear light blending mode and lower the factor to something like 0.1. Multiply the color output of the Voronoi by 100. This will be useful later. For now, preview the Voronoi texture and set your parameters as you want. Here, I'm increasing the texture of the noise to break the Voronoi a bit and also increase the Voronoi scale to get small patches of paper. Now, we can use a face group boundary node and plug the output into the selection socket of an edge split node. As you can see, the face group boundary created a selection on the borders of each color from the Voronoi, splitting the edges on this part essentially. Frame all those nodes, and that's it guys, you've made it to the simulation part! Okay, before adding our cloth simulation modifier, we will create two vertex groups. One that we will call pin, and one that we call shrink. Get a store named attribute node and call the attribute pin. We will use the mask output of the spread solver to influence that pin vertex group we made. Right now, the values are the other way around. As you can see, we want the red part to be the pinned geometry and vice versa. So just use a map range node and flip the values. Then duplicate your node and change the attribute for shrink. Now we want the normal values, so just plug the mask output normally. This tiny gradient from 1 to 0 will stop the cloth from shrinking instantly. Plus you could add more stuff to it, I'll let you try it on your own. We are now ready to use a cloth simulation modifier. And right at the start, I'm gonna collapse those panels and go into the shape panel. I want to reference the pin group. After that, I can open the property weight panel and reference the shrink group. I will use a value of 0.5, so it's not too harsh. Press play, and you can see that our pieces are falling down. We want them to go up in the air, as if the heat was carrying them. So a simple way to do so is just to go in the Scene tab, and into gravity, we can get rid of the minus sign. Press play, and there you have it, your pieces are flying up in the air. Now I'm going to set a few parameters to get a different look on my simulation. All of these are documented, so you can just play around with them or go in the Blender documentation to have a better understanding of what they do. Next step will be to add a turbulence force to this simulation to break the movement of the patches. I'm quickly disabling the cloth sim so I can have a look at the movement of my turbulence when I add the drivers. Press play, and we can see that the movement of our pieces is a bit more chaotic. The final part of this simulation is to set the correct cast duration. You need to see how long it takes for the spread to go across the geometry, and then add a few more frames to the simulation. Otherwise, if you have the same time span as the spread, once it reaches its destination, the pieces will just stop flying. So be careful with that before pressing bake. Here, I'm adding 70 frames extra. I'm renaming the cloth and the turbulence to not confuse them later once we add the smoke simulation. Also, in the collisions panel, I ticked self collisions with the lowest distance possible. This will drastically change the look of the simulation, but also add a lot more bake time. It's up to you to enable it. Now is a good time to save your file, because here we like to play with fire, but we don't like to lose all of that work. Once you're all set, press bake, go grab a coffee and be patient, because this bake can be very long. Once your bake is done, press play and admire it for a few minutes. Then duplicate it, get rid of the cloth modifier, and rename it because you've now reached the smoke simulation part. On that mesh, delete the cloth vertex group and create a new one that you'll call smoke. That's the one that will emit the fire and smoke from our simulation. Add another store named attribute and reference your smoke vertex group inside. Now, we want to emit fire only on the borders of the cloth simulation, so to say. A very easy way to get the edge of that mask is to use one greater than, one less than, and one Boolean math set to end. You can play with both values until you reached your desired thickness. It's pretty intuitive. You can blur this new mask as much as you want now. Be careful, When you plug the blur attribute node between the viewer and the mask, the viewer might still be set to preview a Boolean value. So get rid of it and call it back in order to refresh it. Alright, now with your smoke emitter selected, go into Object, Quick Effects, and choose Quick Smoke. Select your domain and resize it in edit mode. Our plane is very small and we need a good amount of voxels for a nice result. The bigger the domain, the more subdivisions you're gonna need to add. Once you're all set, don't forget to reset your gravity in the Scene tab, just to make sure you don't get any funky result while simulating. It's time to select your smoke emitter, set the flow type to fire plus smoke, because, well, we need fire, you know. Reference your smoke vgroup in the appropriate field, increase the sampling substep for a more stable sim, and tick isPlanar in the flow source panel. I will leave the initial temperature and fuel to their default values, but keep in mind that this can influence the look of your flame. The higher those values, the bigger your flames will be. And if you followed everything correctly, you should already see a flame in solid mode. Now onto the smoke domain parameters. I'm increasing the voxel amount to 92, but for my project I set it up to 132. You don't need to go higher than 164 in my opinion. Here I'm decreasing the CFL number, but in this case it's not very useful. It's a parameter that you should increase when working with fast-moving objects. If you decrease it, on the opposite, you need to increase the time steps minimum and maximum. Those three work in conjunction. After that, I set the buoyancy density and heat to 0.25 to have some kind of slow-moving flame. I'm also adding a tiny bit of vorticity just so that my flame is displaced and not dull. I will enable dissolve with the default parameters. For the reaction speed, I used a value of 4, as this will yield smaller flames. A higher value for flame smoke will result in more smoke emitted by the fire. And I'm adding the same amount of vorticity. Finally, I'm lowering the values of the temperature as these parameters also influence the scale of the flames. This time, for the cache duration, we can set the end frame to be the same as the spread solver, since there shouldn't be any paper burning once it reaches the end of the geometry. Set your cache type to all and tick is resumable so you can interrupt the simulation mid-bake in order to have a look and then resume to where it was left. We will add a bit of noise, which is a parameter that helps us upscale our simulation and add a bit of detail afterwards. The air press factor is pretty self-explanatory. Strength and scale are values for the noise. I'm increasing the scale to get a smaller noise and break my fire even more. The time parameter specifies at which rate the noise texture travels through our simulation. And that's it, you're ready to specify a folder for your simulation. The double / means it will create a folder in the same folder your Blender file is located. The VDB sequence will be stored in there. One last parameter that might be worth looking at is the velocity scale. This parameter tells Blender how much our simulation is influenced by the motion blur. In my case, I disabled it because Blender wouldn't start rendering my animation when it was at 1. It will be stuck at baking the volume cube of the simulation indefinitely. It's pretty weird, yeah, I know. I'll do a quick test bake to see if everything works fine. Then I'll duplicate the turbulence force and lower its strength. Alright, go grab another cup of tea or coffee and see you once everything is baked. And we are now tackling the final part of this effect, the shading. Congratulations if you've made it through. One final effort and you'll be good to go to make your seek render. So we will start by creating the part that is starting to burn, you know, when it gets black before being incandescent. Duplicate a store named attribute and call the attribute preburn or whatever. We will reuse the mask we did for the smoke part alongside a math node set to power in order to be able to adjust the fall-off. Plug that in, open up a shading tab, and find the attribute node. Reference your shrink attribute inside it first, and use the mask as the factor of a mixed color node to alternate between the regular part of the paper and the black one. The paper will look burnt once the mask goes through. After that, reference your preburn attribute in another node to add the effect I was talking about. Here, I'm using a brightness, contrast, and hue saturation value node to change the color of the original texture. After that, we can reuse the smoke attribute to tell Blender where the burning part of the paper should be. We will plug it in the emission socket of the principal BSDF. For the color, you can use a black body node and use the temperature of a candle or whatever suits your need. Here, you can see that I'm not happy with the result, and I'm just duplicating a store named attribute node, call it burning, and add a power node. I could have plugged it in the smoke attribute, but let's just say I didn't make a mistake. Now, let's shade the smoke domain. By default, it should already have a material to it. For us to be able to see the flame, we need to increase the black body intensity to a higher value. 20 will do here. We should also increase the temperature, and you should see your flame now. If you want to customize it even more, you can use a volume info node and shade the volume using the different attributes you have at your disposal. Here, I will use the density socket into a color ramp, which is also plugged to a multiply node. You now have more control over the density and where it should appear. I will duplicate the color ramp and start to give some colors to my smoke using the temperature attribute. The colors are up to you to choose, but here I'm using some reddish color. I'm looking in my original file to see what colors I picked for my animation. Some final tweaks before rendering, which you can do on your own, now that you have all the keys in hand to reproduce this awesome effect. Alright, my friends, and that is it. This was quite a long one, but I wanted to show you how you can build such an advanced effect with a few simple nodes, no complicated vector math needed. I hope you learned a ton of stuff, and as usual, if you have any questions, ask them in the comments. If you like this video, give it a thumbs up, subscribe to this channel, and follow me on social media, Instagram and all that jazz. That's all for me today. Have a good one, take care of yourself, and see you later.